In this video we'll go over the remaining controls from 5.1.3.5 till 5.1.3.10 and conclude with 5.1.4. Control 5.1.3.5. Strict limitation on the use of external storage media refers to the practice of controlling the use of external storage devices, such as USB drives, to prevent the introduction of malware or unauthorized data transfer. This can be achieved by disabling USB ports or using endpoint security software that can detect and block unauthorized devices. When it comes to securing industrial control systems and operational technology, ICS/OT, one important aspect is to strictly limit the use of external storage media. External storage media refers to any type of storage device that is not part of the internal system, such as USB drives, external hard drives, and other similar devices. These devices can be used to introduce malware or other malicious software into the system, so it's important to control and restrict their use in order to minimize the risk of a cyber attack. In order to meet this requirement, one approach is to use endpoint security software that can monitor and control the use of external storage media. These types of software can be configured to block or allow specific types of devices based on their characteristics, such as their vendor, serial number, and other attributes. Additionally, you can use a software that can monitor the files that are being transferred to and from external storage devices and alert you to any suspicious activity, such as the transfer of sensitive files or the introduction of malware. Another approach is to use a security information and event management (SIEM) system that can monitor all the activity on your network, including the use of external storage media. SIEM systems can be configured to alert you to any suspicious activity, such as the introduction of malware or the exfiltration of sensitive data. It's also important to have a strong security policy in place that outlines the acceptable use of external storage media in your organization. This policy should clearly state what types of devices are allowed, what types of files can be transferred, and what types of activity are prohibited. Additionally, it's important to educate employees about the risks of using external storage media and the importance of following the security policy. In Saudi Arabia, many companies are turning to local companies for their security solutions. It's important to use security solutions that are compliant with the regulations and laws in the country, such as the NCAECC requirements. Some local companies in Saudi Arabia provide endpoint security software, SIEM systems, and other security solutions that can help you meet the requirements for secure use of external storage media in your ICS/OT systems. Overall, the key to meeting this requirement is to have a combination of technology and policy in place to monitor and control the use of external storage media. By taking a holistic approach to security, you can minimize the risk of a cyber attack and ensure the confidentiality, integrity, and availability of your ICS/OT systems. Control 5.1.3.6. Strict limitation on connecting mobile devices to industrial production networks refers to the practice of controlling the use of mobile devices, such as smartphones and tablets, to prevent the introduction of malware or unauthorized access to industrial networks. This can be achieved by disabling wireless network access or using mobile device management software that can detect and block unauthorized devices. One of the key requirements of securing industrial control systems, ICS, and operational technology, OT, networks is to strictly limit the use of mobile devices on these networks. This is because mobile devices, such as smartphones and tablets, can introduce a variety of security risks to these systems, such as malware, unauthorized access, and data breaches. To meet this requirement, organizations should implement strict policies and procedures for connecting mobile devices to their ICS/OT networks. This can include requiring devices to be fully patched and updated with the latest security software, as well as implementing encryption and other security controls to protect data on the devices. Organizations may also want to consider using mobile device management (MDM) software to monitor and manage the use of mobile devices on their networks, including implementing remote wipe and other security features. Another important step is to conduct regular security assessments of mobile devices and their configurations to ensure they are in compliance with established security policies and procedures. Another important point is that, when connecting mobile devices to ICS/OT networks, it is also important to use a separate and isolated network to ensure that these devices are not able to access the control systems directly. This can be done by using virtual private network, VPN, and remote access solutions that provide secure access to the ICS/OT network, while also ensuring that the mobile devices are not able to access the control systems directly. In Saudi Arabia, it's important to note that National Cybersecurity Authority, NCA, has issued the OTCC for Operational Technology Cybersecurity Controls that specifically address the security controls for ICS/OT systems, which companies are required to follow to ensure the security of these systems. Control 5137. Periodic review and secure configuration and hardening of industrial, automated, support systems, and devices refers to the practice of regularly reviewing and securing the configuration of industrial systems and devices to prevent unauthorized access or tampering. This can include reviewing the software and firmware versions, disabling unnecessary services and accounts, and applying security patches. Periodic review and secure configuration and hardening of industrial, automated, support systems, and devices is an important control within the domain of industrial control systems cybersecurity. This control ensures that the organization's industrial systems, such as programmable logic controllers, PLCs, supervisory control and data acquisition, SCADA, systems, and other types of automated systems, are configured and hardened to protect against cyber attacks. One way to meet this requirement is to conduct regular vulnerability assessments on these systems to identify any security weaknesses or vulnerabilities. These assessments can be done using specialized tools such as Nessus, OpenVAS, or ICS-CERT, which are specifically designed to scan and identify vulnerabilities in industrial control systems. Once vulnerabilities have been identified, it is important to implement appropriate security controls to mitigate the risk. This can include applying security patches and software updates, configuring firewalls and intrusion detection, prevention systems, and implementing access controls to limit who can access the systems. Another important aspect of meeting this requirement is to ensure that the systems are configured in a secure manner. This can include hardening the system's operating system and applications, disabling unnecessary services and protocols, and implementing security best practices such as the Center for Internet Security, CIS, critical security controls for industrial control systems. It's also important to have a plan in place for regular monitoring and reviewing of these systems. This can include using security information and event management, SIEM, tools to collect and analyze logs from the systems, performing regular penetration testing and vulnerability scans, and implementing continuous monitoring solutions. In summary, securing industrial control systems requires a multi-layered approach that includes regular vulnerability assessments, implementation of security controls, secure configuration, monitoring, and continuous improvement through review and update of the process. Control 5138. Vulnerability Management for Industrial Control Systems and Operational Technology, ICS/OT, refers to the practice of identifying and mitigating vulnerabilities in industrial systems and devices. This can include using vulnerability scanning tools to identify missing patches or misconfigurations, and applying security patches or configurations to remediate the vulnerabilities. Vulnerability Management for Industrial Control Systems and Operational Technology, ICS/OT, is an important aspect of securing these systems. It involves identifying, assessing, and mitigating potential vulnerabilities in these systems that could be exploited by attackers. A key part of vulnerability management is performing regular vulnerability assessments. This typically includes using automated tools to scan the systems and networks to identify known vulnerabilities, as well as manually reviewing the systems to identify potential vulnerabilities. The results of the assessments are then analyzed to prioritize the vulnerabilities based on their potential impact and likelihood of being exploited. Once vulnerabilities have been identified, they need to be addressed. This can include applying software patches or updates, configuring the systems in a more secure manner, or implementing additional security controls. To meet the requirement of 5138, organizations should have a defined process in place for vulnerability management. This process should include regular vulnerability assessments, and a plan for addressing any vulnerabilities that are identified. Additionally, it's important to have a way to track vulnerabilities and ensure that they are being addressed in a timely manner. Tools that can be used for vulnerability management include vulnerability scanners. These are automated tools that can be used to scan systems and networks to identify known vulnerabilities. Examples include Nessus, OpenVAS, and Qualys. Configuration management tools. These tools can be used to check the configuration of systems and networks to identify potential vulnerabilities. Examples include Ansible and Puppet. Asset management tools. These tools can be used to keep track of the systems and networks in an organization, and identify where vulnerabilities may exist. Examples include ServiceNow and Jira. It's important to note that vulnerability management is an ongoing process, and it's important to continuously monitor the system and update the vulnerabilities as soon as the new one found. It's also important to keep in mind that some vulnerabilities may be specific to industrial control systems and operational technology, ICS/OT, and may not be covered by general vulnerability management tools. In these cases, specialized tools and expertise may be required. It's also important to consider that vulnerabilities in ICS/OT can have a greater impact than vulnerabilities in traditional IT systems, as they can directly affect physical processes and equipment. Therefore, it's essential to have a robust vulnerability management program in place to secure these systems and minimize the risk of cyber incidents. Control 5.1.3.9. Patch Management for Industrial Control Systems and Operational Technology, ICS/OT, refers to the practice of applying software updates, security patches, and bug fixes to industrial systems and devices. This is important to keep the systems and devices up to date and to address known vulnerabilities. Patch Management for Industrial Control Systems and Operational Technology, ICS/OT, is a critical control for ensuring the security of these systems. It involves regularly identifying, testing, and applying software updates and security patches to address known vulnerabilities and fix any bugs in the system. This is important because vulnerabilities in ICS/OT systems can be exploited by attackers to gain unauthorized access, disrupt operations, or cause physical damage. One example of a use case for patch management in ICS/OT systems is a vulnerability that is discovered in a programmable logic controller, PLC, that is used to control industrial machinery. The vendor releases a patch to address the vulnerability, and the organization responsible for the PLCs in their facility needs to test and apply the patch to all affected PLCs to prevent attackers from exploiting the vulnerability. There are a number of technology and tools that can be used to implement patch management for ICS/OT systems, depending on the specific system and environment. Some examples include vulnerability management software. This type of software can be used to automatically scan ICS/OT systems to identify known vulnerabilities, and provide guidance on how to apply patches or workarounds. Configuration management software. This type of software can be used to automate the process of testing and applying patches to ICS/OT systems, and to track the status of patches across multiple systems. Network segmentation and isolation. This controls will help in isolating the ICS/OT systems from the rest of the network, by using firewalls and other security measures to limit the ability of attackers to move laterally within the network and reach ICS/OT systems. When implementing patch management for ICS/OT systems, it is important to pay attention to the following points. Identify all the systems and devices that are part of the ICS/OT environment. This includes not only the primary control systems, but also any supporting systems and devices that are connected to the network. Develop a patch management process that is appropriate for the specific systems and devices, including testing and validation procedures. Regularly review the process and make changes as necessary, to ensure that it is effective and efficient. Monitor the systems and devices for signs of compromise, and respond promptly if any issues are identified. Have an incident response plan in place to handle any incident that may occur on the ICS/OT system. Keep an inventory of all devices and software that are part of the ICS/OT environment and make sure all software is licensed and their vendors are providing patches and updates. When implementing patch management for ICS/OT systems, it is important to pay attention to the testing and validation process of the patches before applying them, since these systems are critical and any disruption could cause a major impact on the system availability and safety. Also, it is important to have a rollback plan in case the patch caused any issues. Warning: don't automate patches for critical assets. It's also important to establish a schedule for when patches will be applied, and to ensure that all systems are included in the patch management process. This includes not only the ICS/OT systems. Control 5.1.3.10. Cybersecurity applications management related to the protection of the industrial systems from viruses and malware refers to the practice of using antivirus and anti-malware software to protect industrial systems and devices from malware. This can include using endpoint protection software that can detect and remove malware, and updating the software with the latest virus definitions. Cybersecurity applications management related to the protection of industrial systems from viruses and malware is an important aspect of securing industrial control systems and operational technology, ICS/OT, networks. The goal of this control is to ensure that industrial systems are protected from malicious software, such as viruses and malware, that can disrupt or damage the operation of these systems. One example of a use case for this control would be an industrial facility that uses programmable logic controllers, PLCs, to control the operation of machinery. In this scenario, the facility would need to ensure that the PLCs are protected from malware that could be used to disrupt or damage the machinery. To meet this requirement, a number of different tools and technologies can be used. One key tool is antivirus software, which can be used to detect and remove malware from industrial systems. Other tools that can be used include firewalls, intrusion detection and prevention systems, and security information and event management, SIEM, systems. In addition to these tools, there are a number of best practices that organizations should follow to ensure the security of their industrial systems. These best practices include keeping industrial systems and software updated with the latest security patches, regularly monitoring industrial systems for signs of malware or other security issues, implementing strict access controls to limit who can access industrial systems and what actions they can take, regularly conducting security assessments to identify vulnerabilities and potential attack vectors, having an incident response plan in place in case of a security incident. It's also important to be aware that there is a specific documentation issued by NCA called OTCC, Operation Technology Cybersecurity Controls, which focus on these systems and should be met as well as the ECC requirements to be fully compliant. Control 5.1.4. The cybersecurity requirements related to industrial controls systems and operational technology, ICS/OT, must be reviewed periodically, means that all security controls should be reviewed and updated regularly to ensure that the industrial systems and devices are protected against current threats. It's important to regularly review and update the cybersecurity requirements for your industrial control systems, ICS, and operational technology, OT, to ensure they are still effective in protecting your systems from cyber threats. This review process should be done periodically, at a frequency that makes sense for your organization and the specific risks that you are facing. One key aspect of this review process is to assess the current threat landscape, and check if any new threats or vulnerabilities have emerged that your current controls may not be able to protect against. Additionally, you should also check if any changes have been made to your systems or network that could impact their security, such as updates to software or hardware, or changes in how the systems are used. To perform these reviews, you should have a team of experts who are familiar with the specific technologies and systems that you are using, as well as the latest threats and vulnerabilities that are relevant to your organization. They should also be familiar with the NCA requirements and the OTCC and CSCC. To meet this requirement, you should consider using tools such as vulnerability scanners, penetration testing software, and incident response plans. These tools can help you identify and assess vulnerabilities in your systems, as well as simulate different attack scenarios to test the effectiveness of your controls. Additionally, you should also have a process in place for documenting and reporting the results of these reviews, so that you can demonstrate to the NCA that you are meeting their requirements. You should also have an incident response plan, a crisis management plan, and a business continuity plan in place. This will help you to minimize the impact of any incidents that occur and to ensure that your systems and operations can be quickly recovered in the event of a disruption. It's very important to pay attention to the details and to have a clear understanding of how your systems and networks are configured and how they are used, as well as the potential vulnerabilities that may exist. In this way, you can identify and mitigate potential risks before they can be exploited by attackers. In order to meet these requirements, organizations should have a clear and comprehensive ICS/OT security strategy that addresses all of these controls. Additionally, organizations should have a team of skilled cybersecurity professionals who are familiar with the specific security challenges facing industrial systems and devices, and have the necessary